platform. We had after several years, we have decided to sum up our experience and design a new platform. And this is the outline of today's presentation. I will go through the mechanical design, the visual system, the electrical system, and our raw-based software. And here's about the mechanical design. Our goal is to make a new robot that is lightweight and more importantly, robust to collisions. You know the competition is severe, and our last robots all usually goes failure if we crash too much and some parts are broken, and then the whole robots cannot move and disrupt the competition. And so robust to collision is the main goal. And the second one, the third one is easy to maintain. Because nothing is perfect. It will go broken on after a long time use. It may just go wrong, and you have to maintain it without a lot of effort. And the fourth one is maximum capabilities. We always want a robot that runs faster, that can kick the ball longer, and that's also one of our goals. And we can first start from the base plate. The robots we have about this new design, we have followed a lot of ideas from the TUE, and their robots has inspired us a lot. And here is the base plate of the player. You can see there are several parts here. One is the base plate and the battery and the capacitor, but most important is our wheel module. Here is the wheel model that is designed by ourselves, and we have several features. First is we have direct transmission. That is the motor drives the wheel directly, and it's also very compact because our robots have 4 wheels. Because we want this to be more powerful, so we have chosen a 4-wheel one. And but since you have 4 wheels, and you don't want your base plate to become too large, because it may have slow rotation velocity. So we want it to be compact as much as possible, and also easy maintain. Here is how the whole wheel module can be composite of 4 parts. First is the wheel. That is the old wheels, and this is the supporting part, and this is our new motor driver that is called Elmo, and this is our motor. So when your wheels tears down and you want to replace a new one, you can simply disassembly these 3 screws, and also for the motor you can easily plug in and just set up the screws. You don't have big change. You don't have to tear up the bearing or anything else. You can if the motor broken, you can easily disassemble it and replace a new one. So I think this is a big advantage. And the second part is about the kicking device. You see, this kicking device main feature is about this linear actuator with potentiometer feedback. These two linear actuator can drive the shaft up and down. So you can based on what the kicking mode you want. If you want to make a long shot, you can pull down the shaft, and if you want to just push the ball away with a little gender, you can move it up. If you have a kicking again, to sum up the features of the new kicking device is simplicity. You don't have like TV, like bells or motors or any others. So it's very simple. It's very compact, and it can continuous. It has continuous pace adjustment of the kicking rod, and because of that, you can get a various shooting configuration. So this is about the kicking device, and the third part is about the ball handling device. You know, for the robot, the ball handling device is very important because you have to dribble the ball around, and defense or attack. And here is how it composites. Here is the potential meter. It's about how to get the feedback of where the ball is. When the ball is closer to you, the level will rise up, and it will squeeze the potential meter, and you get a feedback. And here also have a damper, and this is the motor. And one important feature is there's 4 rubber called some kind of nut, and this is also inspired by the TUE. They have their shaft mounted on 2 rubbers, so to absorb the you say when you collide each other, you have great impact and force. So if you mount the whole device on this 4 rubber, when you get impact, you can absorb it and will not break easily. And when designing it, I have do a simple simulation about the ball distance and the sensor readings. This is about the ball distance to the robot. When the ball is completed inside, if I have a 0 distance, and when the ball is completed outside the robot, if I have 25 millimeters, and so we have the range from 0 to 25, and here is the sensor, the potential meter readings, and I have unified it from the maximum and to the minimum, and unified to 1, and with the simulation you can see it's very it has very good linearity. So I think this is an improvement compared to the TUE one. They use the rotation potential meters. And the next part is about the main body. We have adopted this design that is we use a welded mainframe, and this mainframe is to host the computer and the area and every other parts. And you can see inside the frame we have the backup PC, that is the onboard PC, and then we have AutoCAD module and the other electrical device. This design has 2 features. That is, again, it's very lightweight compared to the sheeting or what. And it's very easy to separate between the base plane and the upper body. When I want to check the motors or want to disassemble it, I can just easily set loose the bolts here, and then we can easily take it apart, and change it to another maybe the backup base plate. And the last part is about the visual system have adopted in the new robot. And it has 3 parts. One is the OmniVision, that is for the global positioning. and the normal front camera, and it was used to. It has a down looking and can detect the balls distant from quite from a long range. And then we also have a Kinect here, and it can have a 3D detection on the ball when we're trying to do a pass or catching. And another major change is about the goalie. Still, the whole design is inspired by 2E, but we have changed a little bit. And first is about the Kinect. We have used based on the characteristic of the Kinect. We have a wider field range, and we arrange it like this, so it has a total range of 120 degrees, so it can cover a very large view of the field. And up at the top we have a reserved place for the automobile stereo vision, but right now it's not implemented. And again, the feature is lightweight, and the acceleration of the robots is greatly enhanced because of the layout of the views. And this is the top down view of the whole robot, and you can see these are the wheels and these are the motors. It's very compact and very stable. And the next part of the presentation is about the view system. And this is our omnidirectional vision for the NuBot. The mirror was developed by 2E, but we have and about the mounting point, we have changed a little bit. And so this is the effect of it. And how it came out about we detect the white lines and use for global location, global positioning. And this is the flow diagram of the vision node, how it from grabbing an image and how to process it. So we can just skip the part. And this is about the the Kinect sensor for the goalie. Here we have used the image acquiring and processing with OpenNI and PCL, and this is how it looks like when you combine two Kinects together and detect the ball. Here is the ball. You can see the shape is quite perfect. And about the flow chart, how we use the Kinect. First, we find out the ball candidates with color segment, because it's easier. You can see we color segment with the yellow color, so he can identify where the ball is and cut down the calculation. Then after we have the several ball candidates areas, we use Ransix to fit the sphere to locate where the ball is, and then when the sphere is finding, we will accumulate a history of the ball position, and with this history, we use the parabola fitting with least square method and calculate its trajectory, and then we calculate the touchdown point. And once the touchdown point is calculated, we can tell the robots where to move and defend the goals. Here is the small demo. Yes, you do. And so here's we playing with 3E. And here the goalie has successfully defended a lot of goals, and it's quite amazing. compared to the past. And then I want to talk about the electrical system. In the new robot, we have adopted another, compared to the old one, we have adopted existing solution. That is, we use the industrial PC and with EtherCAT terminals, and we have dropped it our own developed part and use the existing one for the stability and the robustness. Here is it. The commands, the motor commands comes from the EtherCAT and get into the EtherCAT terminals and then goes to the elbow. That's drive the motor, and this component drives the kicker device. And about this on-board PC, we have used the backup industrial PC, and